So this is going to go back basic. I'm sorry if you are bored. I want us all to be on the same page. We're not going to spend as long as I normally do on prerequisite type stuff. So if you don't feel like you need to write all this, you don't have to. But I'm trying to find some holes that students generally have coming out of Algebra 2, starting pre-cal, so that we don't have that issue whenever we get to other things. All right, so we're going to talk about linear equations. Now, when you think linear equations, you probably think about easy linear equation. First of all, what is a linear equation? What does that mean? Okay, so graphically it's a line. How about algebraically? What does a linear equation look like? How can you tell that an equation is linear and not anything else? No exponents. Anything else? Yeah? One what? X and Y. One variable, right? We don't have, I knew that's what you were about to say. Give me an example of a linear equation. More specific. Y equals, instead of the variables in there, just leave X and Y in there. Linear equation, right? That's a graphic. If I were graphing, I'd have Y equals. What if I'm talking about solving linear equations? Like maybe 10 equals That's exactly right. All right, but we see that this is linear, right? There are no exponents on X. There are no additional variables there. We're good with recognizing that being linear, right? And Algebra 2 focused on some other kinds of equations. What did we focus on a lot in Algebra 2? Quadratics, right? We spent a lot of time on quadratics. Then we moved into some polynomials, but we spent a lot of time on quadratics in Algebra 2. All right, so back to linear. If I'm solving, see if y'all remember this. How do I know the order to solve in? Stat map. I'm going backwards order of operations, right? So I'm moving in that stat map, and that tells me what to do first. So the first thing I do is addition or subtraction. And here I'm doing everything backwards, so I'm getting rid of it. I'm trying to get that X by itself. So what do I do first? Come on. Add 7 on both sides. I'm fixing to crank it up, don't worry. Now what? Divide by 3. Easy, right? But let's talk about some things that happen when we're working with even linear equations that might cause us some difficulty. What does every student hate when you see it? It starts with an F, but it's not 4 letters.
Fractions.
Fractions, right? Everybody hates fractions when they see it. Every student all the time. But I need you not to look at me like that, okay? Let's say I have 2/3 X equals 8. Is that still a linear equation? Yes, it doesn't matter that there's a fraction there. It's still a linear equation because I don't have any of those exponents on X. There's just one variable. How can I solve that, though? Multiply by the reciprocal. That's exactly right. What is a reciprocal?
The opposite.
Flip it, right? So here, I'm going to multiply both sides by 3 over. Reciprocals cancel when they multiply. So I have X equals what? 4 times 3 is 12. Everybody okay there? Okay, then. Linear or not? Linear. How is it still linear? Okay, there's just one variable. There's no exponents. And even if I were to multiply this out, it would still be linear. And be very careful because all it would take is making this 2x instead of just a 2 there, and all of a sudden it's not linear anymore. Why? What's 2x times 2x? 4x squared, and now I'm not linear anymore. Okay, so watch that very, very carefully. All right, but we're not 2x on the outside, we're 2. How might I go about solving something that looks like that? Y'all are all right. Let's clean it up, right? Shove everything together, as Brett says. I knew what you meant. That's exactly what we're doing. So we're going to clean up both sides first. Okay, and so by cleaning it up, I want to combine anything that can be combined, but I can't combine them yet because I've got multiplication in there, and I have to do that before I add or subtract. So let's multiply this out. Let's distribute that 2. And I get what? Be careful, watch the sign if you do any type of distributing like this. Again, I know this is easy, y'all, and I know y'all know how to do this. I just want to make sure we're all on the same page. All right, so 3 times x is how can I clean up that left side? Combine like terms. Add the -6 and the 3, the 4x and the 3x. So 4x and 3x. And then -6, 3 would give me. Well, now I've got both sides cleaned up. What can I do now? Get everything together, right? Get the variables together on the same side, the constants together on the other side. So to do that, I'm going to go ahead and move this 5x over. And so I have 2x minus 3. Now I have a 2-step equation, yes? And this is easy. We can all handle it from here, right? I hope. What do I do? And then do what? Divide by 2. Leave it as a fraction. Fractions are our friends, and we are definitely going to need to get more comfortable with fractions, so let's leave it just like that and be done with that. Questions? How do you tell if something is a solution to an equation? How do you test it? Plug it in. If it works, it's a solution, right? If it makes it true. Let's do one a little bit harder. I'm going to give you a second to go over that. Do I have any ideas what we should do? Okay, how might we do that? If I subtract the 2, what's that going to do for me? You're close to what we need to do, though. What's that going to do? Can't believe nobody said it yet. It's a good guess, though.
I know that I don't know it.
Do you notice that I have a bunch of fractions here? And what's not a fraction, I can make a fraction. Okay. What? There's a couple different ways you can tackle a problem like this. If I'm working with fractions like this, my goal is to get rid of the fractions if there are no variables in the denominators. Okay? So the only way I can get rid of these fractions is multiplying through by the least common denominator of all the fractions, right? And that will get rid of the denominator. That'll make them all non-fractions. So what is the least common denominator of 8, 1, and 4? 8. Least common denominator. If I were adding all of these together and I needed a least common denominator, okay? So if I had 1/8 plus 1 over 1 plus 1 over 4, what denominator would you need in order to add them all together? 8, right? So the least common denominator of all of them there is 8. So what I can do is have y'all never learned this method before whenever you're doing fractions?
Probably in like 3rd grade.
So if I multiply everything in the equation by 8, okay, it's going to go to every single piece of the equation. Well, here, if it's in the top and the bottom, it cancels, right? This ends up being 8 times 5y minus 2 over 8 equals 8 times 2 over 1 plus, I'm taking that 8 to everything, and this is a long way to do it, just so you see where it's coming from, because y'all look a little confused. This cancels. So I have 5y minus 2 equals, 8 times 2 is 16, right? 8 divided by 4 is 2. Is this something that's a little easier to solve now? Now, if I asked you how to find y, would you have a more concrete answer for me here? It was still a linear equation, although it didn't look like it. I didn't realize y'all had never seen that way to do it. Did we not do that? No. Do not. But go ahead and solve that and see what you get. Do first, Brett. What'd you do first? Why'd you move the 2y and not the 5y? Okay. Smaller one. I generally move the smaller one to keep it positive if you can. 5 minus 2 is? Now what? Add the 2. What do you get? Y'all good? What is the difference if I were to throw in my gosh? How is this different? You solve it the same for the most part, except if you multiply or divide by a negative, that sign changes. And the reason I really want to hit this is because I want us to review some interval notation. Do y'all remember interval notation? Where we did the domain and the range in interval notation with the brackets and parentheses. All right, so solve it first. Let's go there and solve it. This is an easy solve. Move the 2, right? And divide by -3, but because I'm dividing by a negative, the sign flips. So x is greater than or equal to -5. But I don't want to stop there. I want to write that in interval notation. So in interval notation, what does that look like? Y'all can do this. It hasn't been that
I
long.
don't even remember what interval notation was. No idea.
Say it again. Uh-huh. So this is x is greater than -5, which means yeah. It is a bracket. Why is it a bracket, not a parenthesis? It's inclusive. You're exactly right. It's inclusive, so it's a bracket. And the smallest that x is -5, and then it gets bigger and bigger and bigger forever, which means I'm going to go up to, and infinities always get parentheses, right? This is called interval notation. You could graph it. No, we're not going to graph it because, but this is if you were graphing it, it would be on a number line at -5 going to infinity. What, 2? I subtracted it. You need me to show? Let me give you one more, and then I'll set you loose. Not too hard today. Easy day. Let you work on your homework. What?
Post it on Canvas.
We're going to turn it in physically this year. I'm sorry, I forgot some of you weren't here. We're going to turn it into the baskets on the back wall over there, and then I'll take it up. You'll have a warm up when you come in the morning, and while you're working on that, I'll be handing you back homework. You should have been doing that anyway. Solve for x and put your answer in interval notation. Solve for x and put your answer in interval notation. And I will tell you, if this were me, I would probably do, oh, I got one more to show you after this. I lied. This and one more. I would probably use the LCD method on this, but you don't have to. What we just did. Oh, dear.
It would be 12, right?
Least common, so remember, least common denominator is the same thing as least common multiple, and I'm looking at all the denominators.
So did we change all the modules to 12?
No, it would be, no, Brett, no. What did, say it again?
Last time you did it, you showed us that like you put the bracket and you did 8 over 1.
But why are you multiplying everybody by 4? Well, that's not a multiple of 3. 12 is your least common denominator there. It's your least common one. You got 3 values there. But with a 12 instead of a 4. Now, if you just like working with fractions and you wanted to do 1/3 minus 1/2 or 1/2 minus, then knock yourself out. So 12 divided by 3 is 4x, right? 12 divided by 2 yes. No, only if you multiply or divide by a negative. 12 divided by 4, there is 3. If you did the LCD method here, you should end up with 4x plus 6 is greater than 3x plus 4. Solve it and then write your answer in interval notation. What you looking at, either the LCD method or you figuring out how to solve it?
No, I already did that.
Okay. That is correct. So only when you multiply or divide by a negative number does the sign actually change. Yeah, because he's the distraction in here. You're right. So if it's, look at this one I just wrote. This side would be a parenthesis. This side would be a bracket. If it's included, it's a bracket. If it's not included, it's a parenthesis. And you always go smallest to biggest. It's a bracket. Correct. So this is a compound inequality. This is called an and inequality. Remember, with compound inequalities, we can have ands or ors. And ors are just two separate inequalities, so we won't worry about that. But ands are a little bit different. And so as I solve this, what do I need to do? Where am I trying? Yes, you're exactly right. Where am I trying to get x by itself? In the middle this time, right? So Adam's correct. I'm going to multiply everything by 3. And when I say everything, I mean everything. In the middle, on the left, and on the right. You have to do it everywhere. Do I need to flip any signs right now? Not yet, right? Do we see that? Because I'm not multiplying. This is a negative, but I'm not taking a negative to multiply to it. So this is just negative 9, 2x plus 5, and 15. I did multiply the middle, and it caused them to go away. That's okay. Now what? Solve it. What moves? The 5. Both sides. You're exactly right. Everywhere. Everything's done to everything. So if I do something in the middle, I have to do it to both sides also. So subtract the 5, subtract the 5. I have negative 14, 2x, and 10. I did. Thank you, Brett. So helpful. Appreciate that. It could have. You're absolutely right. Multiply what? Well, I mean, you talking about here? So you could have, but if you do 3 times 2x plus 5 over 3, if you did multiply that out, you'd end up with 6x plus 15, and all of those are divisible by 3. You'd end up with, because that was the denominator. We tried to get rid of it. Yes, divide everything by 2. So I have negative 7, I have x, and I have 5. But I'm not done because I want it in interval notation. So what does it look like in interval notation? Exactly right. Yes. Again, more.